Okay. Pause the recording here. So this video, we're going to focus on 8.3 and getting you guys ready for your quiz. Let me share the 8.3 homework that I downloaded that's not here. Okay, let me pretend that what just happened didn't happen. Pull up 8.3 here. Okay, let me go ahead and share the screen again. Not that screen. Let me see. Let me see. Where am I at?
8.2.
Yeah, no, I know where I am. I thought I had something and let me do this like this. Let me download it because I don't think it downloaded properly. All right, let me see if I can share it this way. Let me go to, oh, I see what I did. It went to I gotcha. I think it went to the other. Yeah, I was looking in the wrong downloads folder. That will do it. So now I have it downloaded 3 separate times. Lovely. Okay. Anyway, technical difficulties, ladies and gentlemen. All right, so here's our issue. Here's the mission before us for this time slot. And that is this. Homework 8.3 t-test for amine. Okay, the first several problems on here are not hypothesis testing. They're preliminary information that you need to be able to use the t-distribution. Okay, so this is in your slides for the PowerPoints. Let me, because I didn't download that, let me show you where those are. These are going to be the usual comprehension questions for that we normally have, like what is the distribution like, all of that. So let me go here and let me make this a little smaller. Go back to, okay. So you guys are familiar with this dance. We've done it before. Here's our 8.3, right? And we're going to go ahead and we're going to download the PowerPoints for 8.3 t-test for the mean. And if you look at the PowerPoints for this lesson, one moment, please, while it downloads. There it is. And I'm going to share, I'm going to have to reshare the screen, I believe. This is going to be, let's see, new share. Yep. 8.3 t-test for me right here. Okay, here is our formula. Very similar to our Z formula. We've seen it before. Okay, here's your assumptions. Finding the critical values, all of that. Okay, inverse function, steps in solving the hypothesis test. Here's your summary. The difference here in this section is we're not going to know what sigma is. Okay, so which test we use, we're not going to have sigma in this section. Okay, no sigma. So the answer here will be no. And then it will be, how large is our sample? If it's larger than 30, we're going to be able to use the z-test anyway with our sample standard deviation in place of sigma. But more often than not, we're not going to have that. We're going to have a small sample size and we're going to have to use the t-test. That's why this is here, okay? And then the rest of our examples focus on that. So that's really the major difference. Now, she didn't give you the assumptions. The assumptions actually come from the textbook. I'm going to give you those here. Let me figure out where I'm at with this one now. Give me a moment. I'm gonna stop that screen share and put up the first question on the homework, by the way, is in what ways is the t-distribution similar to the standard normal, and in what ways is it different from the standard normal distribution? So that's gonna be, it's also in your textbook for those of you who are using the book. Let me put up the is this the one? This is the one. Let me go back to where I need to be for a moment. I'll take you back to this. Okay. So I apologize for the handwriting. It's not too sloppy, but I didn't have a chance to modify this today. So what are the assumptions for your, how is it same, how is it different? Here it is. The T, they're bell-shaped, okay? It's symmetric about the origin, and it approaches but never touches the x-axis, okay? So bell-shaped, symmetric about the mean, and it approaches but never touches the x-axis.
Are you supposed to, okay. That's number one.
This whole, I'm reading it in case, for the sake of people who are watching the video, and maybe, in fact, I should turn on the captions right now. Also, let me turn that on for us. But those are our assumptions. These are assumptions that are familiar to you already. These are not new assumptions. These are old assumptions. We're just comparing them. So the t-distribution is bell-shaped. It is symmetric about the origin, and it approaches but never touches the x-axis. The mean, the median, and the mode are all equal to 0. That's also true for a t, and they're located at the center. Okay, that's your no. But the t-distribution is different. This is, so everything that I just read, from it is bell-shaped down to located at the center of the distribution, those were all the similarities that we have. Okay. The t-distribution differs from the standard normal distribution in that it is a family of curves and the variance is greater than 1. Normally for a standard normal, it's 0. Here it's 1. Here it's greater. As the degrees of freedom increased, so remember, as my sample size increases, right, the t-distribution approaches the standard normal. We saw in chapter 6 that 6 and 7, that the t-distribution can look very skewed for small dfs. Okay, that's the first question. So those are all the assumptions.
I put all that.
Unfortunately, you can use bullet points. You don't have to use full sentences if you don't want to, but you need to get the points across. So bell-shaped, symmetric about the origin. So these are The similarities are going to be, I'll underline them in green. So bell-shaped, symmetric about the origin, and it approaches but never touches the x-axis. The mean, the median, and mode, you can abbreviate if you want. Mean, median, mode, all equal to 0. And they're all located at the center of the distribution. That's all your similarities right here. Your differences, I'll underline in red. Your differences are, here's my differs, in that the t distribution is a family of curves. We knew that before. We learned that last time. The variance is greater than 1. And as the degrees of freedom increase, the t distribution becomes approximately normal. It approaches the standard normal.
The t distribution
Approaches the standard normal. Or you can say becomes approximately normal, if you like. Okay.
Hold on. And the t distribution is a family?
A family of curves. And the variance is greater than 1. Okay.
Then 1.
Yeah. Okay. Are we good with question 1?
Still writing it down. The degrees of what increase? I can't read
The
cursive.
degrees of, that's okay. And as the degrees of freedom increase, the t distribution, you can say becomes approximately normal.
The t distribution approaches
The standard normal. The standard normal
the standard normal.
distribution. Okay.
Okay.
Okay. Now the second question, as I said, this is about your skills that you need for so what we're going to learn to do now is we're going to go back and we're going to learn how to find critical values. Remember, we have instructions for how to find critical values on the slides. They're also available for you I'm going to show you as well, but they are available in the slides and also on Canvas. Okay. The second question here is going to be, let's do this. The second question is going to be find the critical value or values for the t-test for each one. Okay, so this skill is going to relate to us doing the traditional approach. All right. So here, n is going to be 10. Alpha is going to be 0.05. And we're doing a right tail test. Okay. N is 10, alpha is 0.05, and it's right tailed. Okay. Let me show you where the instructions are. You can find them on the slides as well. I think, let me see if I have the slides open. I thought I did, but maybe not. Let me do this and see where I've got. No, I've got the website open. Okay, let me pull them down from here. So if you go to your Canvas page for the t-test, you also find instructions for the critical values, okay? So if it's a right tail test, we have inverse T. Remember, this is the program that's built in. This is not the one you put in. This is your inverse T. Critical value for a right tail is inverse T of 1 minus alpha and the degree of freedom. Okay. If it's a left tail test, it's inverse T with alpha and the degree of freedom. If it's two tails, then that's where we divide the alpha in half. And it's inverse T of 1 minus alpha over 2 and df. So let's look at our situation here. I'm going to share the screen. This is 2A, n is 10. So what is my df for letter 2A?
What happened?
For question 2A, find the critical value for the t-test. What is my degree of freedom? If n is 10, what is my degree of?
Wait, hold on. I forgot A.
Number 8? Where are you?
2A.
Okay. If n is 10, one of the things I need to know to find my critical value is the degree of freedom. What is my degree of freedom for letter 2A?
I don't know.
Degree of freedom is always n minus 1, okay?
Oh.
It hasn't changed. So remember here that your degree of freedom is n minus 1. Let me switch screens and put up the homework, okay? So let me put this up here. So we can look at it. Scroll back to this. Okay, number 2. Ignore the numbers. The numbers here were based on old numbers, but the solutions should work. Okay. So here, what this person did when they wrote the solution out, let me put it on the screen for you, is they wrote the rules up at the top. Okay. So for a right tail test, she wrote CV equals inverse T, 1 minus alpha, degree of freedom. For a left tail, so they're all three are there. Right now we're doing A, and so remember DF here is n minus 1. So 10 minus 1 would be 9, right? This is a this is a right tail test in letter A, we just saw. So you're going to use this first rule here. You're going to use this first rule. Let me spotlight it right here. You're going to use this first rule for a right tail test. Inverse T, 1 minus alpha. And they gave you alpha. Alpha was 0.05. So she wrote critical value equals inverse T, 1 minus 0.05 and 9. Okay. So just to show you what she's doing, let me bring up the calculator here. We're doing for 2A, we're doing second distribution. Inverse T number 4, 1 minus 0.05. My degree of freedom is always 1 less than n, and 1 less than 10 is 9 here. Paste it. And I have 1.8331. 1.83311. Okay, let me see how many decimal places the homework is. So it looks like because the let me scroll down and look at her answer key. Looks like she went to 3 places on the answer key, okay? So your answer to 2A is positive 1.833. Okay?
Yeah, I got that.
All right, now let's do part B. Part B is part B. Let's see. Let me go back to this. Part B here is n is 18. Alpha is equal to 0.10. 2 tails. Okay, so we need 2 tail test. Okay, here's my homework, right? So n is 18. What is my DF in this case?
9.
No, 9 for A. What is it for B? If n is
Oh.
18, what is B? What is
Oh,
DF?
17.
Yeah, 17. And alpha is 0.10, but it's 2 tails. So what it looks like is we're going to follow the rule for a 2-tail test. And a 2-tail test tells us to use plus or minus inverse T, 1 minus alpha divided by 2. And 17 in our DF, right? So in this case, we're going to say for 2B, it's going to be, let me write it here. 2B is the CV is equal to inverse T, 1 minus alpha over 2 and DF. And it's plus or minus this answer. So I'm gonna put plus or minus because it's a 2-tail test. So we're going to have two values that are symmetric. Okay. So what does that mean here? That means we're doing CV is equal to plus or minus inverse T 1 minus our alpha was 0.10. Okay, it's 0.10. We're going to divide that by 2, and our degree of freedom is 1 less than n. So here we have 17. Okay, put it in your calculator. So I'm going to put it in the calculator here. We get second distribution, inverse T, number 4. Here it's 1 minus 0.10 divided by 2 with a degree of freedom of 17. We paste it. We get 1.7396. So the 9 has a 6 behind it. So the 9 becomes a 10. We don't have room for a 10. So it becomes a 0 and the 3 becomes a 4. So this becomes 1.740 plus or minus. So now that's my inverse T function. And that matches, let's see. Plus or minus 1.740, which matches the key. All right, we have 2 more. Let's do C. C says that it is a
Wait. Never mind.
okay.
Oh wait, no, actually, yeah. How do I get the negative version of B?
Okay, you because the T's are symmetric, like the Z's, we just use the plus or minus. We're only putting in for the positive. If you wanted the negative version, you would just use alpha over 2. Not 1 minus alpha, you would just use alpha over 2
Oh,
for that. But the T distributions are symmetric. So if you plug it in, they'll be matching. If it's a true tail, one will be positive, one will be negative. Okay.
okay.
How about C now? N is equal to 6. Alpha is 0.01, left tail.
C?
Part C, 2C. N is equal to 6. Alpha is 0.01, left tail.
DF would be 5.
Correct. Do I split alpha or not?
I don't know.
Okay, let's look at the instructions. Let's check. See. We go back to our instructions here. What does it say for a left tail test? Can you read that?
Which one is it?
For a left tail.
Okay.
It
TDF?
says CV is equal to inverse T of alpha and DF. Alpha and DF. So in this case, we're doing second distribution, inverse T. Alpha is it 0.01? What is my alpha for C?
0.0153.
Now let me check. I'm talking about the homework. Alpha for C is 0.01.
Oh,
I'm looking for the alpha, right? So that's okay. You'll get it. This is 0.01. So we're going to put 0.01 here. And my DF is 5. Okay. 0.01 and my DF is 5. So now my T-score is negative 3.3649. Remember, the 9 makes the digit in front of it go up. So we have negative 3.365 should be our T value.
don't you mean 36? Oh, yeah. Sorry.
No problem, Jason. It's fine. It's fine. We're here to learn the material. So this is not new. It's just the way that we're using it is a little bit new. This should be familiar to you, but it's using it in a different way. Okay. Ready for the last one?
Yes.
Okay. Let's share the last one. All right. So D says N is equal to 9 and alpha is 0.025, but it's a right tail. N is 9, alpha is 0.025, right tail. Let's go to the instructions here. So for a right tail, we're looking at the top right here. Inverse T, 1 minus alpha and DF. Okay. Inverse T of 1 minus alpha and DF. And alpha was 0.025 and is 9. So it's going to look like this. You're going to say that that's equal to second distribution, inverse T, number 4, 1 minus 0.025, and your DF is what?
8.
Yes, very good, 8. Paste it, and you get 2.3060. And we only have one because this is a right tail, so it's positive, and there's only one of them. 2.3060 is your T. Okay.
Mm-hmm.
Now, the other skill that we need is finding p-values. And we're going to do that in a similar way to how we found the Z. These are areas under the curve as well. So we're going to be using our T distribution for that. So let's go and look at this homework problem. After this, after we practice these skills, we get to the hypothesis testing. So I'll be sure, and there's going to be plenty of examples of that. We just need to get through this first. So here, our p-value, we're going to find it. Our test statistic was 2.321. N was equal to 15 and right tail. So again, we're not going to have drawings necessary for step 3, but I want to show you what this looks like. So we're on a T distribution. We're going to assume that it looks something like this. You know, they're going to look a little bit different, but we're going to assume it looks like this. And A is 2.321. So that's going to be somewhere over here, let's say. Okay. My test statistic is going to be here. So this is
Do
2.321.
I draw the graph?
You don't have to. I'm just showing you where she gets the instructions from. You know, I'm not going to do it for everyone, but I want you to kind of see what's going on here. So this is right-tailed. So the right tail, we all know by now, is over here, right? The right tail is going to be this part. What we want to do is find the area here. Again, you have instructions for that. What you'll find is that you're going to be doing this. Your p-value for a right-tailed test is going to be TCDF from T to infinity with your degree of freedom. That's how you're going to find the p-value if it's a right tail. So in this case, it's p-value going to equal TCDF from 2.321 to infinity with a degree of freedom of 14. Okay. So this is going to be, let's go to the calculator. We're going to have the following. Second distribution, look for TCDF, which is number 6 on my window here. Number 6, make sure you get the CDF version. Okay. Your lower is going to be 2.321. Is that what the T was?
Yes.
2.321. My upper is infinity. So we go second, enter exponent on top of number, on top of, is that on top of the log? No. Where is my number?
What?
I'm looking for, whoops, that was the wrong one. I'm looking for my infinity. So this is going to be infinity. On top of the comma, right? Second E, 99. My DF is 14, right?
Mm-hmm.
Paste it, ding. And my p-value is 0.0179. Just like the Z's, my p-values for T's usually around to 4 places. 0.0179 is my p-value here. Okay.
Okay, because on the answer sheet, it says that p-value equals 0.018.
Oh, she rounded to 3. Okay. Well, then, if you want to match the answer sheet, you round to 3 places. She'll specify where you should round to, okay? So here, if you remember, if this, and this is good practice for those of you who need some practice rounding, this is, if this is going to be 3 places, we're going to look at the 7. There's a 9 behind it. So that means that this 7 goes up and we end up with 0.018 if we did that. So she's rounding to 3. Okay. All righty, let's go to the next problem. The next part says T is 1.945, N is 28, and it's two tails. Now, 1.945, 28, and two tails. Two tails, we haven't done too much with, so I'm going to show you that. Two tails is going to follow the second. So I'm looking at the second group and it's two tails. Then I have my, if it's greater than or less than, but it's going to be twice whatever I get from the distribution. Okay. Here it's positive, so I'm looking at the bottom rule. It's 2 times TCDF of my T, infinity, and DF. So it looks like this. I'm going to have 2 times, and you enter the 2 independently of your TCDF, 2 times second distribution, TCDF, 1.945, 945. 27, because our, so I'm sorry, to infinity, right? So this is going to be infinity here. Oops, no. Infinity. So this is second E99. And my degree of freedom is 27. .0623 is where this would go, or 0.062 is what I have here. Okay. Now, if it's a negative and it's to the left,
Oh, there's two values for this one.
no, no. P-values, there's ever only one of them. We just multiplied it by 2 because it was 2 tails. You're thinking about critical values. P-values, there's ever only one p-value for. Okay. So 0.062 is your p-value there. Okay.
0.062.
0.062. Let's go back to C. Let's go back to C. All right. All right. So T here is negative 1.267. N is 8, and it's left tail. Negative 1.267 and 8. So here we're going to have this. My p-value is going to be p-value is going to equal the left tail. So I'm going to have T CDF, okay, and it's going to be from negative infinity, so negative E99 to my t-score, which is negative 1.267, negative 1.267, and my degree of freedom is going to be 7. Okay, poke that in your calculator. Let's do it. So we have second distribution, in TCDF, number 6, negative infinity to negative 1.267. My degree of freedom is how much? Let's see. 7, right?
Yep.
Okay, my degree of freedom is 7. So I'll just 7 in there. Delete that. I don't want 77. No. And I'm going to paste it. And I end up with 0.122 or 123 because there's an 8 behind it. 0.123 is my value there. Okay. Going on to letter D. We have T equals 1.562, N is 17, and it's 2 tails. Anytime you have a 2-tail test, you're only going to have one p-value, but you'll double whatever you get. You're going to double that. So you have this. Number D is going to look like this. 1.562 and 17. So we're going to have this. We're going to have 2 times. Now, depends on where my T value was. This is positive. So I'm going to be going toward infinity. So I'm going to have two times TCDF. So second distribution, TCDF number 6. My lower is 1 point, whatever it was. Let me see. 1 point, was it 562? Yeah, 1.562 with a degree of freedom of 16. So this is 562. My degree of freedom is 16. Oops, my upper is infinity. Forgot that, got ahead of myself there. My upper is infinity. My degree of freedom is 16. Paste it. And if you have 2 times that, you get 0.1378 is my p-value for that.
Six, 2, 9, 17. Oh, 16.
16 is my, yeah, DF is 16.
0.138.
7 or 138. Yeah, if you round it, it's 138. Very good. Okay. Good news now is we get to do hypothesis testing. Okay. So this is very similar. You'll see it. It's a little time consuming, but there's not a lot of new material. We covered all the new stuff, how to find the test statistics, how to find the p-values, how to find the critical. Okay, that was all the new stuff. So the rest of this, other than just using the t's, should seem familiar to you. Let me grab number 4 right now. Here's the problem. And then I'll grab number 4 and we'll look at it. The average strawberry has approximately 200 seeds. A very patient student selected a random sample of 10 strawberries and found a sample mean of 185.2 seeds with a standard deviation of 10. At the 0.05 level of significance, can it be concluded that the mean is less than 200? So let me take a couple of notes and then we'll do this hypothesis test. Remember, she did not state that it had to be p-value. She didn't say that anywhere. If she doesn't state that, you are to use the traditional method. You are to use the critical values. Okay, so critical value for number 4. Okay, so we know that mu is 200. And we know that we have a sample of 10. So we also know what my DF is. And we know that the sample mean X bar was equal to 185.2 with a standard deviation S. Remember that's S because it goes with the sample. A sample standard deviation of 10. Can it be concluded at the 0.05 level, alpha is 0.05, that the mean is less than 200? So here's what it's going to look like. Let me open up the whiteboard and we'll do this one together. So this is problem 4. Starts the same way, all right? This is going to be parameter equals population mean equals mu, okay? That hasn't changed. Second thing you're going to write, if you're going to write that you're using your claim here, your claim is that H1 oops, H1 mu is less than, oops, mu is less than 200. Okay. We're using the traditional approach. And we're using, we have our givens, right? Our given quantities. And for our given quantities, we have N is 10. DF is equal to N minus 1, which is equal to 9. And then we have X bar. So X bar was 185.2. This is 185.2. And my S was 10. Okay. Now, we need to figure out which test we're going to be doing. So for the test that we're going to be doing, we ask ourselves, is sigma known? And the answer is no, it's not. We know S, we don't know sigma. Sigma known, no. And is N greater than or equal to 30? Well, our sample size is only 10, so that's also no. And so therefore, we use a t-test. We use a t-test. All right, that's all your preliminaries. Now we're going to start the 5 steps. So step 1, we write our hypotheses. Okay, so step 1 is going to be HO. Remember, our claim is less than, so our null is going to be mu is greater than or equal to 200 here. And we have to write the statistical equivalent to it. So I'm going to draw this arrow thing in the middle. And our statistical equivalent going to be HO mu equals 200. Okay. Now our H1 is going to be mu is less than 200. That's going to mean we have a left-tailed test. Left-tailed test. So any questions about this part?
No.
No. Step 2, remember, this is the traditional approach. So step 2, we get a critical value. So we're back to doing what we did in exercise number 2. We're finding critical values for a left tail test. Now, my DF is 9. So here, my critical value, I'm going to have one of them, right? And my critical value here is going to be, you can look back on the chart or in the notes if you need help. I'm just going to write it here. Critical value for this is going to be T, which is going to equal inverse T. I'm sorry, not inverse T. It's going to be TCDF. And since it's left tail, it's going to go from negative. Actually, I'm sorry. I got ahead of myself. It is critical. So it's inverse T. It's inverse T. I was thinking we were doing the p-value approach. Inverse T of my my alpha, which I didn't write my alpha down. Under my givens, I should have written my alpha. I didn't do that. Let me check it. My alpha is 0.05. So make sure that you put this on the quiz. These will be in blanks. You'll have to report each of these. Alpha is 0.05. So here, this is going to be, I'll put it here. Alpha is 0.05. Okay. Alpha is 0.05. So you're going to say 0.05 when it's your left tail. And your degree of freedom we have that written down. It's 1 less than n. That's 9. So my critical value, I mean, my critical value, let me do it off screen. This is second distribution, inverse t, 0.05 divide, and we're doing 9 is my df. Paste it, and I get negative 1.833. That's convenient. Okay. So this is negative 1.83 is my critical value. So this is negative 1.833. You want the redecimal, okay? Now I'm going to calculate my test statistic. Very similar to the Z. This is not hard. This is what we did before. So we're going to calculate our test statistic with our formula. So this is going to be, this is my, remember my test statistic formula T is equal to X bar minus mu. The only difference here is your X. So this is X bar minus mu over S divided by the square root of N. That's my formula. So this is going to be X bar is 185.2. Let me put it on screen. This is 185.2 minus my mean, which is 200. And then I'm going to divide that by S is 10 divided. Now, be a little careful here. Sometimes students mix this up. This value is N, it's not DF. So 10 divided by whatever N was, that's 10. Okay. Sometimes if you get it wrong or if it seems slightly off, make sure you put N down here. Okay. Let's do the calculation. That I will do on screen for you so that you can follow here. This is going to be 185.2 minus 200 divided by 10 divided by the square root of 10. Okay. And what I get for that is negative 4.680 is my T. Negative 4.680. So here I have negative 4.680 is my T. Now, remember, this is the traditional approach. So we do draw in this case. So we have number 4. We're going to reject or not reject based on my how my test statistic compares to my critical value. Okay? So what's happening here is I'm going to say reject HO or do not reject HO. And so I'm going to draw my curve. And it's going to look something like this. It should look fairly normal. Okay, your critical value was negative 1.83. So maybe that's this value right here. This is CV, and its T is equal to negative 1.833. Whoops. 1.833. My test statistic that I just calculated is all the way over here somewhere. Okay, we don't know exactly where, but we do know that it's more negative than the T value. So I'm going to bring it down here a little bit so I have space to put my box. This is my test statistic, so this is my T, and I'm going to write test next to it just to remind myself that that's the test statistic that I got. This is negative 4.680
Where'd you get that from?
from the calculator. Remember?
Oh, yeah.
We went here. This is coming from here. Okay. The test statistic comes from the actual givens. The critical values come from the alpha. All right. So we have, oops, except I wrote the wrong. Okay. So this is going to be my test statistic. Test statistic. Going to be T is equal to a negative 4.680. And we can see from the diagram that your test statistic clearly falls past the critical value, which would lead us to reject HO. Because it's in the region, we reject the null. Okay. And then step 5, we summarize we conclude and we summarize. So here, we're going to say, based on the fact that we rejected the null and our claim was the alternative, remember? And I didn't write that anywhere. I need to do that. I just realized that here I left something out. I'm going to put claim next to H1. So claim goes next to H1 in your don't forget to write that. Okay, so here I have there is enough evidence to, now your claim is H1, so we have to support the claim because we have the claim is H1 and there is enough evidence because we rejected the null. Don't forget to underline your is and support. So here you're going to underline is and support. there is enough evidence to support the claim. And that's your hypothesis test for number 4. Okay.
Mm-hmm.
Now, before we get too far into it, I want to do one with a p-value so that you see that. Just so you can see the difference to it. So I'm gonna stop sharing this. Let's do, let's see. Let's do number, okay, that's I want to find a p-value approach. Okay, let's, did she ask you for p's? It looks like she, let me see. I mean, before I lie, but it doesn't look like she asked you to do P's. And if that's the case, I know which one I want to do with you because I know which one is probably going to give you problems the most. Let me see if there's a p-value here. Okay, the only one that specifically uses the p-value is number 11. Okay, and it's raw data. So let's go ahead and do number 11 as a p-value. A report by the Gallup poll stated that on average, a woman visits her physician 5.8 times a year. The researcher randomly selects 20 women and obtains the data 3, 8, 2, 0, 1, 5, 3, 6, 7, 4, 2, 2, 9, 1, 4, 3, 6, 4, and 6, 1. All right, at alpha is 0.05. Can it be concluded that the average is still 5.8 per year? Mu is 5.8. Okay. This will give us a chance to do a lot of things. So I think we'll use this as an opportunity to help ourselves. First thing you need to do is put your data in your calculator because you need S and you need X bar, okay? So we're going to put the data in our calculator, stat, edit, okay? I'm gonna clear my data out. Second memory, clear all list number 4. And I'm gonna put the data in there. So we have 3, 8, so 3, 8, 2, oops, 8, 2, 0, 1, 5, 1, 5, 3, 6, 7, 4, 2, 2, 7, 4, 2, 2, 9, 1, oops, 9, 1, 4, 3, oops, 4, 3, 6, 4, and 6, 1. Okay, once you put the data in your calculator, we're going to go to Stat. We're going to go to Calc. We're going to go to one var stats. Enter. L1, calculate it. Pay attention to the top X bar right here. Pay attention to this here. Pay attention to SX right here. Okay. X bar is 3.85. SX is equal to 2. I'm going to go 4 places just because I don't know how many she needs right now. So I'm going to say 2.5189 is what I'm going to call this. It normally goes one more place than your data, so she may have just gone to 2.5, but she has a tendency to go to 4, so I'm going to honor that.
What does SX mean?
SX is the same as S,
Oh,
the same as S.
and how much I'm putting in?
I'm sorry, was that?
How much decimal?
I'm using 4. I don't know what she will specify. So she'll specify for you what she wants, but she's been using 4, so I'm going to go with that just for the sake of this example. Okay. It's not going to make a huge difference in the T. So it shouldn't change the conclusion of your hypothesis test. Okay.
Mm-hmm.
All right. So now we know the drill, right?
Oh, and N is 20.
N is 20. Good job. We need that. What else do we need, Jason? When we're working with T's.
The sigma.
No, we don't have sigma. We have S instead. But what is it that we get from N? Do you remember?
The DF.
Right. So what is my DF here?
19.
19. Good. So we know the drill. We've been to this rodeo more than once. Okay. So we're gonna, let me get another whiteboard here. This is number 11. Okay. So here we are, number 11. All right. So we're going to do our thing here. We're going to say that the parameter is the population mean mu. Okay, population mean mu. We're going to say that the claim was, we wanted to know if women go to this doctor at the same amount, right? So our claim here is mu equals 5.8 because we're claiming that they go the same, I believe, if I remember correctly. Can it be concluded that the average is still 5.8? Right. So we're claiming that it's equal, right? So we're going to say mu equals 5.8. That means that this happens to be my HO this time. This is a little bit not new, but it's been uncommon. Our claim has normally been H1, but it can be either. This is HO. Okay, so claim is HO, stick that in there. I don't want to erase this. So claim is HO, mu equals 5.8. Okay, and I'm doing the p-value approach. So I'm going to indicate that. This is my p-value approach. And I'm also going to put the givens that we just discussed that we got from the calculator. If you got them from the calculated raw data, they're still considered to be given to you. N is equal to 20. DF is equal to 19, N minus 1. My my S, which remember was SX on my calculator, my S was equal to 2.5189. And my X bar was 3.85. So my X bar here, just use that as a handy little tool there. X bar, this is 3.85. Okay.
Mm-hmm.
All right. And my alpha was 0.05. Is that right? My alpha was 0.05. So this is going to be alpha is 0.05. So, okay. There it is. All right. Now, same rodeo, same 5 steps. Remember, after the initial step, we get the test statistic. This is where it's different, but step 1 is the same. So step 1, we're going to get our null and our alternative, state the claim and the direction of our test. So we have step 1 here. This is going to be HO. We have mu. We have, let's see, it's equal versus not equal this time. So this, we haven't seen too much of this, but this is going to be mu equals 5.8. And that's actually going to be the claim this time, because we want to know if it's still that or not. Is it still this? Is it equal to this still? Claim. And this is going to be, we're going to, our H1 here is going to be mu is not equal to 5.8. So not equal to 5.8. And this is a two-tail test. Okay. So you're going to write two-tail here. Two-tailed test. Okay. Don't forget to write your statistical equivalent. We don't have a statistical equivalent here because it is equal already. Okay. If we had something else, we would need to write this again, but we have this. So if she asks you to write it, you can write it again, but it's the statistical equivalent is the same. Okay. Okay. So step 2, remember, is our test statistic because we're doing the p-value approach. So here we're going to go with our test statistic. Same formula. So we have T. This is T is equal to X bar minus mu over sigma divided by the square root of n. So I'm sorry, S divided by the square root of n. So this is S divided by the square root of n. Now, my going to say here, my X bar, remember, came from the calculator, 3.85 minus my mean, which is 5.8 over S, which also came from the calculator, 2.5189 divided by the square root of 20. Okay, so we have divided by the square root of 20.
That is.
Now we're gonna plug this in. I'll do it on screen for you. 3.85 minus 5.8. So oops, wrong screen share, sorry. So we have 2.85 or 3.85 minus 5.8 divided by open pairing. This is 2 point, what was it? This was 2.5189. Okay. So we have 2.5189 divided by the square root of 20. Make sure you move your cursor. T is negative 3.462. T is negative 3.462. Jason,
I
are you
got
ready for
the
that?
answer.
You
I
got
got the
that.
same answer.
Cool. All right. So now let's do this. This is going to be negative 3.462. So we have 3.462, right? And then we get, now we go to step 3, which is, now we get our p-value. Remember, drawing is not necessary, but if it helps you, you can, but you need to include the instructions. This is where you go to the p-value instructions. This is why we did exercise 3 earlier when we were doing p-values. This is why. So your p-value here, and we have another chance to go over this because this is a little bit uncommon. It's a two-tailed test, okay? So it's going to be plus or minus. Remember, they're symmetric. So one of them's positive, one of them's negative. We're finding the positive one with this method. So this is plus or minus. Okay. This is going to be T, yeah, TCDF. I had to stop and think about that for a minute. TCDF, and it's going to be 2 times that, right? Because I have a two tail. So 2 times TCDF. And I'm going to go from my T-score. And actually now, this is a case where we did a positive one before. So let me show you that. Let me go to the instructions because the two-tail test that we did before was a right-tailed one. This is a left-tailed one. This will give you a chance to see it. So if you look at the p-value instructions here, you scroll up. Here's your p-value instructions for a two-tailed test. What changes here is which infinity you start from. That's why these instructions are different. So you're going to go from negative infinity to the T-score, okay? This probability value is going to be positive, but your T will be negative, all right? So here you get this. You have TCDF from negative infinity, so I'm going to write negative E99 to my T, which is negative 3.462. And remember, I need my degree of freedom. So my degree of freedom is 19. Okay. I'll do this. This is going to come from the calculator. We're going to get it right now. So here we're going to go to TCDF. So second distribution, TCDF, number 6. Okay. We're going to go from negative infinity. Remember, use the little negative, the little minus next to the enter key for your minus sign. E99, negative 3 point, is it 462? Is that what I said? Let me check.
Mm-hmm.
Is that the, I think so. Let me double check it.
Yep.
Yeah, negative 3.462 and 19. So now this is 19. Don't be thrown up by the 16. That was the previous problem that we did. Here's my numbers. Okay, there they are. My p-value is really small. Okay, it's now question is, did I double this? I think I did, but I can't remember. You know what? I didn't double it in my calculator. So I'm going to go back. I forgot to put in 2 times. So I'm going to go ahead and say that this is second distribution. Okay, let me just, you know what I'm going to do? I have it in the calculator still. Okay. But if this happens to you, no need to panic. Okay, this is my TCDF. I forgot to double this. Okay. You can double it right now. So just go ahead and double your answer. If you forgot to put 2 times in front of it, it's like I did. Go ahead and double your answer. That'll come out the same. Your p-value here is 0.0026, okay? If you doubled it the first time, you'll get the answer that you see down here as my second one. 0.0026 is your p-value, okay? So let's do this. We have my p-value is 0.0026. So here it is. 0.0026 is my p. Now, step 4, we've been to this rodeo. It's reject or do not reject the null. So we're going to say, now when we're doing p-value approach, we're comparing p to alpha. Okay, so we reject HO or do not reject HO. Okay, reject HO. And we're going to compare P to alpha. So compare, you don't have to write this next part, compare P to alpha, but I'm reminding you here. Compare P to alpha. You do need to write the next thing I write down. Your p-value is what we just got, which is 0.0026. So you're going to say 0.0026. You're going to compare that to alpha. Alpha, remember, comes from the problem. It should be with your givens. This is 0.05. Okay. Now, is your p-value smaller or larger than your alpha?
The p-value is smaller.
Very much so, right? Smaller than alpha. So you're going to write that. You can write p above your p-value. P is less than alpha. Okay. And so what do we say? We reject the null, right? So you write, you reject the null, reject HO, because P is less than alpha. P is P is less than alpha. Good. So we're going to reject the null. And then we write our summary statement. We draw our conclusion. There's my reject HO. Here comes step 5. Step 5 is going to be, we rejected the null. The claim was the null. Okay, that's something that we haven't seen too much of. So we're going to say, again, refer to your flow chart if you need help, but you're going to say there is enough evidence to reject the claim. This is the first one that we've seen worded this way. There is enough evidence because we rejected and the claim happened to be HO. So there is enough evidence to reject the claim. Underline is and underline reject. There is enough evidence to reject the claim. And that, my friends, is how we do a p-value hypothesis test for a T, okay? I hope that this video has been helpful. I'm going to stop the recording.